in this section, we try to be familiar with the surfaces in R3. Once the equation is given, let us see how we sketch the appropriate graph. Now, in this case, we need to consider several objects like sphere, ellipsoid, paraboloid, plane, cylinder, and so on. So, first in part A, let us consider the sphere. Here, let us consider the sphere of radius r centered at the origin. We saw it is like the circle in R2, but you have an additional variable. So, x squared plus y squared plus z squared is equal to r squared. So, this is how you sketch it. You take the horizontal line, measure about 30 degrees, for this is the x axis, this is the y axis, downwards upward direction. You keep the z axis as the vertical axis. This is like the isometric drawing. Now, you sketch the circle of radius r and then draw a circle which encircles this one. So, this is the sphere of radius r, this is the radius, right. Now, when it comes to ellipsoid, if you have like different coefficients in x squared, y squared and z squared, you have to make the right hand side equal to 1. So, you arrange it into this form. Now, you know that when these two variables are 0, like both x and y are equal to 0, so you get x squared is equal to a squared, which gives you x is equal to a, x is equal to minus a. Because on the x axis, both y and z coordinates are 0. Now, likewise, you know that the y intercepts are plus or minus b and the z intercepts are plus or minus c. Now, you first see the intersection of that with xy plane. So, this here I took b which is less than a, like so. You connect this one and then complete the ellipsoid. It is like an egg, right. Approximately it looks like this. Now, we will move to paraboloid. First, let us consider parabolas, some parabolas in R2. This is also a parabola. Paraboloid can be obtained by rotating this parabola about its axis. Now, this y equals x squared, we are already familiar with this one and we are already familiar with this as well. And remember, here the axis, this is the axis of the parabola. Here in the equation, the axis is not squared, it remains as y. Here, this is the axis. So, the x axis is the axis of the parabola, and here even though y is squared, x is not squared and x is in the other side. Similarly, here let us consider a paraboloid now. You have all three variables, but two of them are squared, like here x and y are squared, but z is not. Therefore, the variable which is not squared remains as its axis. So, z should be the axis, but we will see how we sketch this. We have to do some groundwork. So, we know that for all positive real, for all real values of x and y, x squared plus y squared is non-negative. That means, this is greater than or equal to 0. Now, instead of x squared plus y squared, you plug in z plus 4 here. So, if you take 4 to the other side, you get z is greater than or equal to minus 4. So, it is greater than or equal to minus 4. So, it always exists above this point. Now, what happens at this point? When z is equal to minus 4, if you plug in minus 4, you get x squared plus y squared is equal to 0. That gives you both x and y are equal to 0. So, that means it is this point, because both x and y are equal to 0 means that you are on the x axis and its z value is minus 4. Now just to for the sake of clarity, let us see what happens when z is equal to 0. Z is equal to 0 means xy plane. The plane contains both x's, x and y. At z equals 0, you plug in 0 here. So, you will end up with x squared plus y squared is equal to 4. So, it is a circle of radius 2 on xy plane. So, it is like this. You draw the isometric view like this. And then this is a point, and always you can see that now here the radius is 2, but if you want to have radius 3, you need to have 9 here. That means Z should be 5. So it goes like this, like a parabola. Like this. If you just cut this diagram parallel to xy plane, you always get a circle like this, right? It's like one of these, right? Like if you rotate this about its axis, you will end up with a paraboloid. Now we will move to the next diagram, which is cone. Before addressing what it is, let us consider this one. Y squared is equal to x squared. Here both variables are squared, but they sit in opposite sides, not in the same side. If they are in the same side, you get a sphere, but you have a circle. But here you have them in opposite sides. So let us see what the diagram indicated by this equation. So take x squared to this side, you factor this. Now you have a product which is equal to 0. That means each one should be equal to 0. So this will give you this straight line, and the second will give you this straight line. So you get pair of straight lines in this case. But what happens if you rotate this about this axis? If you then you get a cone. So again, let us come up with the figure in 3D. Some equation in 3D. Here you have both. Here you have only 2 variables. Here you have 3 variables, but one is in one side and the other variables are in the other side. Here you can see that if you take this side, like in the case of parabola, x squared plus y squared is always greater than or equal to 0, because they are non-negative. But x squared plus y squared is z squared. We know that z squared is always greater than 0. That means z can be any real value. It can be anything, right? So Z, for positive values, for the negative values of Z, the diagram exists, the object exists. When Z is equal to R, what happens? When Z is equal to R, you plug in R there, x squared plus y squared is R squared. So when Z is R, that means if you take any horizontal plane, it's always a circle. But when R is equal to 0, it is a point. X squared plus y squared is 0 means both x and y are equal to 0. Here it goes through this one. After that, for positive value of say 5, x squared plus y squared is 25. When z equals 5, it's a circle of radius 5. What happens when z is minus 5? Still it's a circle of radius 5. So you can just take one plane like this. You can draw a circle there. It goes this way as well, but for the sake of simplicity, I will keep it like this. So if you want, you can draw it like this. So this is a cone. Right. So in the cone, you can only see that in the case of a cone, you have all 3 variables squared, but 2 variables are in one side, 1 variable is in the other side. That variable which is isolated acts as the axis of the cone. Now look, axis is Z, Z is like this, right. Now, let us move to the next one, it is plane, it is a very important one. Now, if you take the plane, for example, if you have some equation, you can make the right hand side equal to 0, sorry, equal to 1. Then if you do that, you will end up with something like this. So, these numbers, like in the case of a straight line, gives you the axis intercepts. That means what? When both y and z are equal to 0, x is equal to 6. So, that means the plane intersects x axis at 6, because on the x axis the other variables are equal to 0. Similarly, to find like when both x and z, these two are equal to 0, you get y is equal to 3. That means the plane intersects y axis at y is equal to 3. So, you can just mark those points, and here it is 2. Now, you form this, and you can draw some lines like this just to say that, like, you consider the portion of the plane inside the first octant. Similarly, take this one. In that case, there is no z intercept, because there is no, I mean, z is absent, I mean, z is not appearing there. So, x intercept is 2, y intercept is 3. You draw this one, but it does not intercept is, I mean, it does not intercept z axis. That means what? When two things are parallel, they do not intersect. That means this plane is parallel to the z axis. It is always true for any object. If one variable is not present in the equation, that object is parallel to that axis. So, it is a plane like this, right. Now, finally, let us come to the cylinder. We could have discussed this earlier, but before discussing this one, before seeing that what happens when one variable is absent, you cannot get into the last topic, cylinder. That is why I wanted to discuss this one first. Now, in the case of a cylinder, it looks like the circle, like the sphere, but in the sphere all the variables are squared and all of them are in one side. Look, in the case of a sphere, all the variables are squared, all the variables are in one side, and their coefficients are equal, 1, 1, 1, right. In the case of a paraboloid, you have all the variables, all of them are in one side, and all the coefficients have the same sign, either they are positive, right, all of them are positive, but they have different values. Here they are the same, they have the same values, they have different values. That makes, I mean, once you have different values there, you will get the ellipsoid. In the case of a paraboloid, you have all three variables, but one variable is not squared and it is in the other side, right. In the case of a cone, all the variables are squared, like in the circle, like in the paraboloid. However, one variable is in one side and two variables are in the other side, right. One variable is in one side, some side, and the other two variables are in the other side, right. So, that gives you the cone. But in the case of a cylinder, one variable is missing. You have only two variables, but all of them are squared like the sphere, but one variable is missing. That means what? Since one variable is missing, you know that the object is parallel to the variable which is missing, parallel to the axis corresponding to the variable missing. Now, here, because of that, you simply consider this as a circle in R2, sketch the diagram in R2. So, it is radius 2. So, you have intercepts are like this. So, you draw the circle of radius 2 on xy plane, then it is, since it is parallel to the z axis, you pull this like along the z axis upward and downward. So, you get a cylinder like this. If you want here also, you can you can see the cylindrical shape of it. And here the missing variable is y, that means it should be parallel to the y axis this way. So, sketch the circle on xz plane, circle of radius 1, and then pull it along the y axis. So, it is like that. Okay. All right. With this, this discussion will be over, and you will, these shapes will be useful when we get into vector fields. Now, to vector fields as well as the multiple integrals, to find the areas, to find the density, volume once the variable density is given, or to find some charge, total charge once the charge density is given. You need to know the shape of the object once the equation is given. So, that is why you need this. This section is over with this one. So, in section 2, we consider the normal lines and tangent planes, right, to surfaces, as well as tangent lines and normal planes to space curves, how you find them using vectors, right. Okay. Thank you.